correlation calculation straight with the wind speed, the temperature, and precipitation, but it's not coming through. It's not coming through. I don't know what I'm getting wrong.
Okay, so in this time for that correlation, we can also use the Python. It also possible to use the Python. For that, we need the two time series chart. One is for that, suppose chlorophyll, another is for the temperature. Okay, so when you can get the two time series chart for the chlorophyll and temperature, then you can easily use the Python and make the correlation using the Python programming language. Okay, so now do you have this time series chart? Did you create?
No, I didn't create. Like I was thinking, USA it has to be done in Python itself because actually I don't have a coding idea on Python. So I don't know. We're gonna create it in GE and then transport it to Python. I don't know.
Okay. So what we can do for that?
Do we have to create a time series chart from Google Earth Engine to Python, or it has to be done all together in Python?
Okay, so you can send me the previous link which you work. Just send me the link.
Which link? To the previous code that we did?
Yeah, why your time series chart, where you can create the time series chart, send me the link.
Okay.
In the monthly time series chart, where you can put first, I think previous time.
But can we use the time series chart that we already created before using the 1000 plot point? Can we use that?
Okay, send me that, I check it.
Let me send you this thing. It's I sent already.
Okay, let me open that.
The only thing is I sent two time series chart. I mean two code. We have to use the second code. We can use the time series argument in the first code to incorporate it in the second code because we have to use the data set in the second code. Remember, the first code has a data set that mainly just focus on ocean core field, so that will advise not to be used. So if we can use the data set in the second code, it'll be fine.
But second code has the another problem. It not work for that across the limit of 5,000 element. It not generate the time series chart.
Oh,
Suppose here you can see it's one kind of time series chart we already created for monthly concentration and also kill the monthly average. So it very work very well. This data set work very well. But when you want to work for this as your another code, but this code is not created when it will be across the limit for 5,000 element. So this is the another problem for that. Okay.
Okay.
So this is the another problem for doing that, because it's not work for across the limit of 5,000 element for monthly time series chart is not created. But in this time we can already get the time series chart, two time series chart. Here you can see one is that monthly average time series chart of chlorophyll, another is for temperature. So now I can easily download the time series data from here as a CSV file, download from here, and further I can easily work with that in Python for making the correlation. So let me show you that. So there you can see this is the time series chart for LST. Just I try to open it. Just okay, open. So it show me the LST time series chart, and you can see it already. So the another thing is for that mainly for chlorophyll. So I download the CSV file for chlorophyll also. So when you can get the two time series chart, then we can easily use it to make the correlation. Suppose I just simply copy this things from here. All of the data simply copy, and I simply copy this column, and I want to merge these two chart in a one Excel file. Okay, so just I simply paste in here. Just I paste this data in my this Excel file. I simply paste here. Not copied, so let me check. So just I copy from here, and then I merge these two chart in one Excel file. So just paste here. So now here you can see we can get the two column. One column is for LST, another column is chlorophyll. We can get it. So now we are just use these two things and then try to make the analysis correlation. Mainly correlation we can easily find out from here the two data set. In this time it also some extra data, so just I try to remove that. It not need. Or we can do another thing. Suppose I just simply copy my data set. I put the name. Suppose it's the LST, and this is the chlorophyll, and it's a time. So this is the time, and further I simply copy from here. Just copy from here, and I create a new Excel file, and then I paste here. It's my data set. Okay, so this my one is the time series data, another is my LST and chlorophyll. So now this data set I simply save it as a CSV file. So I just save it in here. So just I save it as a CSV.
Now,
I save it as a data set. So now I create my data set. So now I use this data set to make the correlation using Python. So for that, I just simply open my Google Colab. In this time, I do it using your Google Colab, and we can easily find out that correlation with our time series chart, LST, and also for that. Okay. So let me open. I have changed my Gmail ID. Over there. Okay, so just I try to find out that. Okay, not right. We try to write the code again. It also better.
I just sent you the code for the entire time period, like 2000 to 2020. Can we use that?
Okay, no problem. He also tried to do for the same process. Okay, it's not enough for the same data. So data set, when you can create this type of data set, here you can see in this time I create this type of data set. And when you create any kind of data set, you try to use the same process. Okay, this when you can get the data set, further we are use the data set to make the correlation. The process is the same. You try. I will send you the recorded class also. You try. Okay, so now I just try to import this data set in my Google Colab. So click on here, and further I just simply connecting with my Google Drive with my here. So you can see, simply click on here, Mount Drive, and connect to Google Drive. And further you can see run the code in here. Connect to Google Drive. And I choose my Gmail ID. Okay, for in this time, I just simply click on the continue. And then further click to continue. Okay, so now you can in this time it show about that Google Drive also. Okay, just I click on here. Okay, you can say Drive. Okay, Drive is now connecting with my Google Drive is connected with my Google Colab. So click on here. You can I go to my Drive, and I try to create a folder. Suppose I just click on here and then create a new folder. Suppose I put the folder name, suppose correlation. So now further you can see there's a folder. I simply click on this folder, and then you can see upload option. So now I simply upload my data set which I created already in here. This is my data set is simply imported. So now you can see this data set is the imported as a CSV file. Okay, then click to the OK. So now I simply import my some important library for doing the correlation. So just I simply import a library. It's called the Pandas. So just import Pandas as PD. I also need to import the sklearn dataset. Import. It's not needed. Not needed. We not the sklearn dataset. We are just use the same dataset, and also import the seaborn as SNS. We also import the matplotlib. So put here the matplot library dot pyplot as plt. Okay, just I simply import all of the necessary library and click to run. So now this all of this library is successfully imported in my dataset. And further in this time, I just take a variable. Suppose I put the variable name is that df, and I call the pandas library. So mainly pd dot read csv. I call this function and I simply copy this path link. You can see copy this path and paste here. So now further click to the run. Okay, it also okay, you can see. So now I want to show the data set. Just simply put at the df and click to the run. So now you can see it show me the data set, basically time, LST, and chlorophyll. You can find out from here. Okay, you can see show the data set. So further, after doing these things, we are just applying the correlation. So in this time for the correlation, for that we have to use some value in here. Suppose I take a variable, suppose correlation equal to df dot suppose I put the correlation, and then I put at the method. So put here the method equal. I put the method, suppose Pearson. So just put here the Pearson method and click to run. Okay, it show the error. Okay, this time it show the error. Okay, oh yeah. So in this time we take a variable, suppose correlation, and then I call the NumPy library. So basically in this time we need the NumPy library. So it's called the NumPy library. So we also need to import the NumPy library also in here. So for that I simply import a new library, NumPy as np. I run the code again. And further I take a variable correlation, and then I call the np NumPy library and correlation coefficient. I try to calculate, and I have to calculate from that df. It's my data set. From this data I choose a column name which is lst, and also choose the another column name which is the df, and put the column name, suppose it's called that your another column which is the chlorophyll. So I simply copy this column name, and further I just try to add in here. Okay, so in this time I call the np library, calculate the correlation coefficient. I call the column name, two column name, which column I want to use for that correlation. Click to the run. Okay, so now it's okay. You can so you can get this type of things, and then further I just try to print that. So just CORR. In this time I print the variable. So now it show me about the correlation between that. You can see. So we can see that it show the correlation between the LST and also chlorophyll. Between that we can get it. Okay, you can get the 0.1 and also get the 0.1. We can match from the above correlation matrix table. It was the same. We can get also the same result when you want to work for the other correlation method. We can get the same result also from here. Okay, so in this time I want to plot the figure about this correlation. I want to plot the figure. For that, I just simply click on here and I call the PLT, mainly your matplotlib, put at the figure. I put the figure size, so fig size equal 10 comma suppose 10.8. This is the size value I put in here, 10.8. And I also put the resolution DPI equal to suppose 500. Further, I just simply call the SNS and keep the heat map. I want to create the heat map about this correlation. Heat map and call the correlation, which I already make the correlation, and put at the anode equal to true, and put the formatting. So if you have the FMT, then I put at that these two things, 0.2f, the two floating number I take in here, and also mention about the line width. So put here the line width equal to suppose 0.5 pixel. So now try to plot this heat map. What the problem? Okay, it's showing the problem. PLT figure, yeah. Seaborn has not attribute heat map. Okay. I already imported the NSS library, so here you can see it's that SNS already imported. Yeah. Okay, we try to add the another plot. Just a minute. We try to add the scatter plot. Suppose I call the PLT. I call the scatter, and I call the data mainly. Okay, DF data. I call the DF. Copy from here to data. Okay, so it show you this type of figure. The yes one can show about that LST. So it show the LST, and it show about the chlorophyll value. We can get this type of figure. So in this time, we create the regression line. Okay, for that regression line, what we can do? Okay, so in this time we try to make the two variable x and y about that, and further we are just trying to find out that plot, mainly slope, intercept. Okay, all of this thing we try to plot in here. So for that we can just use it. So I just take a new cell. I put calculate the slope, then intercept, then R value, then P value, and also calculate the standard deviation error equal to, I call the SciPy SciPy dot stats dot linear grace between that two things, x comma y. Okay, basically x is that LST and y is the chlorophyll. In this time we have to import this library, so for that I just take a new cell and import the SciPy that's okay, it's also okay. So now it's okay, and further we try to add the line about the chart. So for that I just take a variable, suppose line equal if I put here that it's a regression line. Okay, then y equal to mx plus c. So here y equal to m, mainly mx plus c. So here I put here the c, mainly intercept. So I call the intercept which is the c and paste here. And further I put here the two floating number. So just put here the two floating number taken here. And these things will be plus, it will be plus addition with mx, m mainly slope. So I just call the slope from here. So slope and paste here slope, and slope will be two floating number. So just I put here the 2f, two floating number, and further we put here that mx, so mainly slope into x. So just I put here the x, then comma, then r value I want to show. So r equal, just make a dictionary and put here that r value. So r, I put the two floating numbers. So put here the 2f. Okay, two floating number I put in here. And further I just simply put the this type of things. Okay, so now click to the run. In this time what's happening, you can click to the run in here. Okay, so it got that. Okay, so it's a lowercase l. So now click to the run. Okay. Okay, Linre. Okay, sorry. Lin. Its spelling is the wrong. Linregres. Okay, now try to check. Yeah, so that's okay. And further click the run. And then also print the line. So now we can easily get the value about that. Intercept value, slope value. Okay. So now I can see it provide me about the, it's a R value 0.11, and we can get that it's a intercept value and we also get about that it's a slope value, mainly linear equation y equal to mx. M is the slope, mx plus c is the intercept. Okay, so this is our regression line equation. Okay, and this is the r value, r equal to 0.01. In this time I want to plot it, then it also more better about the correlation. So we find out the regression line, and now I want to make the plot about that regression line and also plot it, so then it also more better. So for that, in this time we are just make the plot. So how I can put the plot? Very easy. Just we try to you can see here. Suppose I just take a very just put at the figure. Suppose FIG figure figure ax equal to, I just put at the PLT plot and then create a subplot. So just put the subplots, and further I just create the plot, mainly ax dot plot plot, and then call the xy. X mainly our LST and y mainly chlorophyll. I already defined x and y. And further I just put here that a line width. So put here the line width equal to 0. I put the 0 line width, and I put the marker. I will add some style about this chart. So put here the marker equal to I put the symbol for S as a marker. It's a marker symbol. And then a label. So put here that label equal to, I put here the label mainly data points. I put the label name is the data points. Okay. So now further, after doing this, adding this type of things, we have to call the ax dot plot, and I call the x mainly your it's a LST, and then call the intercept. So I put here the intercept value, intercept plus slope value. It's multiply with x. Okay, multiply with x value, and further I put the in here put the level. This level it's a line, so I put here that it's a line. So it's a line 11. And further, after doing these things, we try to add here the x dot set x level. So put here the x level, and put here the x level, and put here the x, and further ax dot set x level, and put here that, so it's a y level. So put here the set as a y level. So it's put here the y. So it's a y level. Okay. Okay. So we put that set x level x and y level y, and further we also add here the legend. Suppose ax dot legend. So put here the legend, and legend mainly in this time I put the legend color. So I put the legend color, suppose white color background. So just put here that face color, mainly face color. Set the face color equal to white. Okay. And further we want to show the plot. So PLT dot show. So now it show about that plot. So now click to the run. Now let's check what happened. Okay, it show the plot. The problem it's showing here. Okay, it's so we can see. Okay. So in this time we can get this type of plot here. You can see here we can get the R value equal to 0.11 and regression line equal to this, the regression line, and it's our chart. Okay, and it's the y and it's the x. Okay, mainly what is the y? Y is mainly it's called for that your, I also write the name. Suppose it's a chlorophyll. Suppose I put the chlorophyll, CSLOR, and it's for that temperature. Okay, temperature. Just I put at the temperature. So now click to the run. In this time we can get this type of things here. You can see this is our temperature data, this is our chlorophyll data, and further we are just make the regression line y equal to mx plus c, and we can get the r equal to 0.11. So we can find out the positive correlation between the chlorophyll and temperature. Mainly chlorophyll concentration when high, then temperature is also high. Suppose you can see this is the point, it's the high chlorophyll concentration and also high for the temperature. Okay, so basically this is the process. I again explain one by one this code, then it can also better for you. So first of all, I simply connect my drive. So this is my drive, I simply connect, and then further I simply import my CSV file in here in my folder. I simply import all of necessary library, and I simply read this my CSV file. I simply copy the path from here. Just simply copy the path and paste it. And further I simply show the dataset. Just I print that, it will be show my dataset, mainly LST and chlorophyll. After doing these things, we try to calculate the correlation using the NumPy. So call the NumPy and put the correlation coefficient, mainly R value, between the LST and chlorophyll. You can get this type of result. And we also show the plot about that, plot scatter. Okay. And further in this time, we are just import this library, and I take a variable X which is stored the LST data, and take the another variable Y which is stored that mainly your chlorophyll data. Then I calculate the slope, intercept, R, P, standard deviation using this function. Okay. And further I simply make the regression line about that. It's a regression line. We can find out the regression line for this data set, y equal to mx plus c. We find out the c value, it's the c value, and we find out the m value 1.60 and is x value, and r equal to 0.11. We find out the positive correlation between these two data sets. And further here you can see I just simply plot this data set. We can get this type of plot. Okay, so it's about the chlorophyll and temperature correlation. Any kind of time series data set between two variable, when you want to work, just apply the same process all time. Okay, so we can got this idea about that, how we can easily use the Python to make the correlation and also make the time series chart about the correlation. So in this time it's show about that. You can see regression line, this is the formula about that, also the R value about that. So all of those things we can easily get from here. Okay, and this is the chart about that. So basically in this time, when you want to do that, you have to create the time series chart, same interval. Suppose LST monthly time series chart, you also take the LST chlorophyll monthly time series chart. Then you have to use the same code for doing the correlation, and also make the correlation chart or regression line chart. We can easily create from here. Okay.